So absolute maximum and absolute minimum are the biggest and the smallest values that you get for a y value over a particular interval sometimes. So this one, they're saying, don't look at the whole function, just look between x equals -2 and x equals 1. Now, since it's a continuous function, then we have a shortcut. We don't have to use a graphing calculator or some sort of cheat code or something like that. We can just look at the endpoints. So x equals -2, x equals 1. Those are potential places for the maximum and the minimum. And then the only other place would be at critical points, where the first derivative equals 0. Okay, so I'm going to find the derivative of this function. And then I'm going to set the derivative equal to 0. That's a quick equation that we can do. We factor out an x, so you get x equals 0 and x equals 4. Those are the critical points for this function. Now I'm going to scratch this one out because 4 isn't even in my interval. X equals 0 is possible. So now we have three values that have the potential maximum and minimum. It's got to be either x equals -2, x equals 1, or x equals 0. If we plug those into the function, -2 cubed is -8. So this is -8 thirds. Subtracted by -2 squared is 4. 4 times 2 makes 8. So that's -8 over 3 subtracted by 24 over 3. So that's -32 over 3. Let's see if we can beat it. If you plug in x equals 1, oh, I forgot the plus 4. Oh, that serves me right for trying to go too quickly. Okay, if you plug in x equals -2, then -2 cubed is -8. If you plug in -2 here, -2 squared is 4, so 4 times 2 makes 8. And then if we simplify, that's -8 over 3 subtracted by 4. So it's -8 over 3 subtracted by 12 over 3. So it's -20 over 3. Okay. So that might be a minimum. Let's check out the other ones though. If you plug in if you plug in x equals 1 into the function, you get 1/3 subtracted by 2 plus 4. So that's 1/3 plus 2. So that's 1/3 plus 6 over 3. That makes 7 over 3. And then if we plug in x equals 0, this is 0, 0, 4, we get 4. Okay, so on this interval, y equals 4 is the largest possible value that occurs at x equals 0. And then x equals -2 gives us our lowest possible value. So an absolute minimum occurs at, that's what the y value is. -20 over 3 is our absolute minimum. That occurs at x equals -2. Oh, I got those reversed. And then an absolute maximum. If we plug in x equals 0, we get y equals 4. So an absolute maximum of y equals 4 occurs when x equals 0. Absolute minimum and absolute maximum, remember, they happen either on the endpoints of the interval or at the critical points. So x equals -4, x equals 5, those are two places we want to consider, but we also want the derivative of x. We want to set the derivative equal to 0, solve for x, and those are critical points. So we can use the quotient rule to evaluate this derivative. It's the derivative of the top function times the bottom function kept the same, subtracted by the top function kept the same, times the derivative of the bottom function, all over the bottom function squared. And simplifying a bit, that's 2x squared minus x squared, so that makes -x squared plus 9 in the numerator. And then we got, oh, this whole bottom function needs to be squared. X squared plus 9 squared. Careful, those don't cancel out though. Okay. So we set the derivative equal to 0. And the rationale there is, like, if it's a continuous function, look, the maximum and minimum of this crazy function I just drew, they happen when the slope is 0. So when you're plugging in 0 in for the derivative, you're plugging in 0, you're finding out where the slope of zeros occur. So we said critical points happen where the derivative fails to exist. So we would want to look at the numerator. But there's no value of x you can plug in here to get out -9 so that you would have a divide by 0 problem. But that's just for a future problem. If we had an x squared minus 9, then x equals 3 and x equals -3 would be critical points to test out. Okay, so that's no problem, no chance to divide by 0 problem. Multiply both sides by x squared plus 9 squared. That gets rid of this. We have a smaller equation to solve. Subtract that 9 from both sides. Divide -1 from both sides and take a square root, so we get 2. We get -3 and +3. So we have 4 values to test. X equals -4, x equals -3, x equals 3, and x equals 5. So maybe make a table. So -4, -3, 3, and 5. And if you plug -4 into the function, you get -4 in the numerator over -4 squared. 16. 16 plus 9 makes 25. I'm drawing an arrow for this one. If you plug in -3, and then you get -3 over 9 plus 9 makes 18. So that can be simplified. That's -1 over 6. If you plug in 3, then it's just going to be the opposite sign, right? 1, 6. And then if you plug in 5, that's going to be 5 over 25 plus 9 makes 36. Wait, 25 plus 9 makes 34. Sorry. Oof. Bad math there. So it looks like 5 over 34. 5 over 34. Oh, okay. I mean, I had a moment where I was doubting myself here. 1 6 is bigger than 5 34ths, right? Because 6 34, yeah, I don't know. The maximum value here, of all these y values, the biggest y value is 1 6. Just barely beats this fraction. So this is our maximum. That would be our absolute maximum. It occurs at x equals 3, and the maximum is 1 6. And then the lowest value here, -4 over 25, that's -0.16. This x equals -3 is a little bit lower. That's our minimum.